Good afternoon, class. Thank you. You can sit down. All right. In our last lesson, we looked at transposing of the family, and we did on the exercise questions 4, 9, 12, 15, 19, and 22. Now we'll have to correct all the other questions. And then if we have time, we'll start on the second type of equation, which is quadratic equations. We've done simple equations, and now we're going to look at quadratic equations. Okay, we'll just go around the class to see what answers you've got. The first 7 questions, 1 through to 7. Okay, we'll start from Geno. Okay, since the mic is here, we'll start from the front. Patrick. We'll start from Patrick. Number 1.
D equals C over pi.
D equals?
C over pi.
C over pi. Number 2, Livingston.
V equals C over P.
V equals?
C over P.
C over P. Lester.
H equals V square over 2G.
Over?
2G.
2G. Okay. 4. 5.
Over X.
A equals?
A equals U over X.
U equals?
U equals AX.
AX. Number 6. Kyle. Stand up.
N equals 0.866 over D.
0.866 over D. Number 7, tau.
L equals H times 33,000 over PAN.
Is that right? Um, 8. Solomon.
P equals 14.7 over 1 minus 1.
P equals 14.7 minus P divided by small letter P. Are you sure? Big letter P. You're supposed to make big letter P the subject of the equation. That's what it says. Small letter P. Two small p's. Oh no, it should be big letter P. Okay, your answer should be small letter P plus 4.7 is equal to P. Okay, P equals small letter P plus 14.7. Okay, number 10, Bui. Please stand up and answer the question.
X equals 5 times 1 minus 17.
5 times?
Y minus 17.
Sorry. You mean like that? 5 times y minus 17. Like this. Okay. Number 11. Velma.
B minus A over C.
Equals what? X is
X.
equal to B minus A over C. Okay, that's correct. Number 13. Ekoi.
H equals S over pi r minus r.
H equals S over pi
Pi
r
r.
minus r. Okay. Number 14. Chutaili.
N is equals to 2CP plus small letter n.
Okay, correct. Those are the answers to questions 1 to 14. Okay, question 16 to 21, you will have to come and do the questions on the board. So, then question 16, Miriam, question 17, Gabriel, question 18, Peter, 20, and Garonamo, 21. Okay, quickly, just chalk here. And then we'll look at if you disagree with any of the answers we've got on the board, then we'll look at them again. All right, just have a look at these two questions before we continue. Question 16, first she squared both sides and then got v squared equals 2gh and then divided by 2g. She got h equals v squared over 2g. 16 is correct. Number 17, first of all, she squared both sides of the equation. I want you to note that there's a slight mistake here. When you square one side of the equation, it has to be everything. So you're supposed to square this. Otherwise, you can divide by 2 pi on both sides, and then after that, you square both sides. So this one should be 4 pi squared. Okay, this one should be also 4 pi squared, because pi is also squared. This one 4 pi squared. So the answer should be L equals t squared g over 4 pi squared. All right, next one. So next two people come and do 18 and 20. Factorize and take. Okay, have a look at this one. If, okay, what he's done is he's moved that and then he divided by v squared, which is not correct. You are supposed to, because you are adding, you can add and subtract both sides at the same time, but you cannot do two different, like you cannot divide and subtract. You can divide and multiply, but you cannot divide and subtract or add. Okay, so you're supposed to move MGR to this side. The answer is probably correct, but I don't know. Okay, we'll look at it. Add MGR and then you factorize and get M. So the next step should be, okay, PR equals MV squared plus MGR. Okay, and then you take out M, you get V squared plus GR equals PR. We want M on one side of the equation, so M is equal to PR over V squared plus GR. Okay, so the answer is not right. So take note, although I said earlier you can actually do two things at the same time. You don't divide, like you don't add and then divide. You got to move this because this one has got an M attached to it. So add first and then factorize and then divide. Okay, this one V squared is equal to 2k times 1 over x minus 1 over a. What do we want? H. Should be k. Sorry, a. Okay, so we want a. First, he divided by 2k, which is correct. And then v squared over 2k equals 1 over x minus 1 over a. And then you have to multiply by ax, because ax is the lowest common multiple of x and a. So you will get from here, let me just remove this. Okay, from this point, you will get v squared over 2k equals 1 over x minus 1 over a. We want a, so multiply by ax on both sides because that's the lowest common multiple of a and x. So when I do that, I will get ax v squared over 2k. Are you following? Okay, and then equals, I multiply this by ax and I also have to multiply this by ax. Okay, and then I will get x minus a, sorry, the other way around, a minus x. Okay, we want a, now we can add x on both sides, so, sorry, there's an a here. Multiply by 2k. And I will get 2k times a minus x equals ax v squared. And then I have to multiply by 2k, so I get 2ak minus 2kx. Okay, equals ax v squared. Now I can bring the a's together. I'll bring 2kx to the left hand side and subtract ax v squared. So 2ak minus ax v squared. And then I factorize. So I'll get a times 2k minus x v squared equals 2kx. And then I divide by 2k minus x v squared to get a on one side. So a is equal to 2kx all over 2k minus x v squared. Did I make any mistake? Okay, so the first step you divide by 2k and then multiply. Okay, what I should have done was to make it a little bit faster, I should have multiplied by 2k xa, because that's the lowest common multiple of 2k x and a. But it's okay so long as you know you're multiplying. So I multiplied by ax first and then I multiplied by 2k on both sides. Is it clear? Okay, that's the answer for question 20. Right, the last one, question 21. Okay, have a look at question 21. How many people agree with Garon Amos' answer? Nobody? Any other answers then? Any other answers for question 21? Nobody has another answer? If you disagree with her answer, then you should have 20 other answers in the class. Anyone willing to give us their answer? No? Kila, what's yours? Can I wrap this now? Where's the mic? Huh? What do you mean you don't have any answer? Lester? No. Okay. I want you to note, please listen in case you are given another question like this. 2 root 2hr minus h squared. Remember when we looked at basic numeracy, we said if you write something like this, 2 root 2, that means 2 multiplied by the square root of 2. So this means 2 multiplied by the square root of 2hr minus h squared. Okay. There are 2 ways to do this question. I'll just do it the way she's tried to do it here, and she made a mistake somewhere. The first thing that she did was she squared both sides, which is correct, and she got 4 times 2hr minus h squared. Now her mistake is this, and I see this a lot. Instead of writing the multiplication sign, put brackets, because when you do that, you will know that you are multiplying this by 4. I've seen that when students write multiplying and then they don't write it, they don't write this, they're going, which is wrong. Because it says this multiplied by all of this. So if you're squaring, 4 has to be multiplied by this. Okay, I'll do this both ways and see if we get the same answer. Now, this one should be 8HR minus 4H squared. We want H to be the subject of the equation, so we factorize H times 8R, sorry, 4H, won't make any difference. Okay, 4H times 2R minus H. No, we'll take out 4 only. 4 first. 4 times H R minus, sorry, 2HR minus H squared. Okay, then we divide by 4. We will get C squared over 4 equals 2HR minus H squared. Okay, the reason why I didn't take H out as well was this. If I take out 4H, I will now have 4H times 2R minus H. I will end up with a H here, and I will also have a H on the other side, which is not supposed to be. Remember what I said? H must be only on one side of the equation, not both. Okay, so now we factorize. We now have H. There's still a H somewhere. There must be a mistake. It can't be. Okay, if I divide by that, I get H. Because if we factorize, we're going to get 2R minus H. That's the only way we can do this. And then if I divide by 2R minus H, I can't because I'll have a H and a H on the other side. We are back to square one. Unless there's a mistake. I'm sure there's a mistake. Okay, if I divide by 2R. Okay, let's try it another way. C squared over, sorry, C over 2 equals the square root of 2HR minus H squared. And then it will still be the same. C squared over 4. If I square both sides, I get C squared over 4, and then I'll have 2HR minus H squared. If I factorize, I will get H, and I will still end up with 2R minus H over, sorry, equals C squared over 4, which is exactly the same as this one. That's why I said you can actually do it both ways and still come up with the same answer. Unless, I think this is supposed to be M. Huh? If I find the square root of both sides, I'll have to bring this to this side and then subtract this one, and then I'll say H is equal to the square root of, but then there's still a H there. So you can't go any further. This one you'll have to end up with a H on both sides of the equation, which is not supposed to be. I think we'll make this one N, but the way it is, this is how far you can go. H is equal to C squared over 4, and then all of it is divided by 2R minus H, which goes against the rule, because you're supposed to have one H only on one side of the equation. This one is h. And this is h equals c squared over 4 times 2r minus h. I'll have to check the answer out. I mean the question. But did you go as far as this? Okay, then you've done the right thing. But you have to note, there's only, h must be only on one side of the equation, not both. Any questions so far? Any questions on the ones that we've done? If you have any questions, then please say so. 20? Oh, that's the one I've explained. That's how far you can go on question 21. You can't go any further. Okay, I got this by just multiplying this by 1 over 2r minus h, because I'm dividing by 2r minus h. I'm sure there's a mistake. Okay, we'll go on and look at quadratic equations. Okay, we'll just start it off and then we'll complete it in the next lesson. Okay, the general form of a quadratic equation okay, I'll just use E, Q, and N with the line below N to mean equation. So the general form of a quadratic equation is given by ax squared plus bx plus c. It must have an equal sign and it will have to be equal to 0, where a, b, and c are what type of numbers? Real numbers. Good, you at least can remember, are real numbers. And a must never be equal to 0, because if it is equal to 0, it is no longer a quadratic equation. Okay, I think these notes when we looked at quadratic expressions, factorizing quadratic expressions, but I just said ax squared plus bx plus c. If it is equal to 0, then it is a quadratic equation and not an expression. Okay, examples of, it has the highest degree in the equation is 2. So it is called an equation of degree 2, which means the highest power in the equation is 2. For instance, I'm going to write 3 types of quadratic equations. 3x squared is equal to 0. 3x squared plus 3x is equal to 0. Note, okay, please listen, 3x squared, if 3x squared is equal to 0, that means a is 3, the coefficient of x squared is a, the coefficient of x is b, and c is always the constant, it's always by itself. So in this equation, 3x squared equals 0. A is 3, b is 0, and c is also 0. Note, b and c can be any number, only a cannot be 0. All right, 3x squared plus 3x, what's the value for a here? 3. The value for b? 3. The value for c? 0. 6 equals 0. The value for A is? B? B? 0. C is -6. Right, the last type, 3x squared minus 6x plus 3 equals 0. This time, A is 3, B is -6, and C is +3. So there will be times when the equations will be written in any of these 4 ways. Sometimes it can be written like this, 3x squared minus 6x, and then this 3 will go on to the other side. But so long as x or the unknown is raised to the power of 2, that is a quadratic equation. It will always be in the form ax squared plus bx plus c. So please take note of that. That's how you recognize quadratic equations. Okay, when we come next lesson, we are going to learn how to solve quadratic equations. There are 3 methods that we learn. One, I think you learned last year, and that is factorizing. That's the first one. The other 2 are probably new. After that, we will also learn word problems. We will also learn to solve word problems involving quadratic equations. And with that, I want you to note the difference between a word problem that involves simple equation and a word problem that will involve a quadratic equation. Okay, but we'll look at that next time. This is how far we can go in the time that we have. All right, I'll let you go to your next lesson. The keyword to the pilot teacher is quadratic.